Welcome to Electric Universe Geometry, where I, Buddy James, am dedicated to interviewing doctors, lawyers, physicists, engineers, and much more to get to the bottom of what this electric plasma universe is made of. Thank you for joining us for episode 3. Thank you for being here today for Electric Universe Geometry. Today we are interviewing Ethan Clark with Broadcast Theory, one of my favorite episodes I've done thus far. We get deep into the ideas of transmitter-induced ozone depletion, ionic acoustic waves, and much more. This is a solo operation. Best way to support me is on PayPal, goldenscaling@gmail.com. Sorry, as a little precursor before the episode starts, the connection isn't the best, so it's a little rough to listen to, but it's worth your time. So please take the time to check it out. Thank you.
But I'm looking forward to the show, and thanks for asking and having me on and such. So
yeah, I love your content. You really drew my eye with quite a bit of the stuff that you're talking about here, and the stuff that I'm talking about. But let me welcome the audience real quick. You are the third guest here on the Electric Universe Geometry. That is, it's really broad, but really kind of directed as well. It's pointed. We know it's an electromagnetic universe, plasma electromagnetic universe. Some people call it PEM, PEM. But either way, thank you for being here. This is the third episode. I plan on interviewing everybody throughout the whole. I mean, I literally had an awakening, a vision when I was 19 years old in 2003, and it really shook the core of my foundation. So I've gone out, and now I'm looking and to try to understand different people's perspective as to what's really going on with space weather, and space news. So my first place, of course, to go was, well, one of them was the Thunderbolts project, and so I met up with them. And long story short, now I'm gonna do this for as long as I have blood in my system, because this is where it's at. This is what it is. I didn't even know half this stuff existed, and my geometry just happened to just sit right there in the center. So I can't wait to see how our geometries coincide, and your content. And yeah, enough about me. Let's hear about your what you have to present to the table here. This is really exciting.
yeah, so a lot of my research has to do with understanding how various electromagnetic radio waves affect climate dynamics, and that's kind of a big thing that I've focused on specifically. I originally got started with this. I was actually doing research for a CO2 climate change website. I was going to be doing some graphical work, and I wanted to dive in deeper. I wanted to be a part of the solution and understand how to help convey some of the scientific knowledge that was out there to a wider audience, and just really be a part of that. In that process of kind of diving in to understand how the various dynamics worked, there were some really good questions that I couldn't ignore. And one of those specifically was a period in our climate's history called the Early 20th Century Warming period. And that was from about 1910 to about 1945. And the book of the warming in that period was from 1925 to 1944. There was a kind of a huge warming trend in that region. And according to all research in line with the IPCC, there simply wasn't enough CO2 in the atmosphere to account for that warming trend. In fact, all like climate models that that CO2 will show the current warming trend, they don't show the warming period of the early 20th century warming period. So that became this big mystery to me. What is this? What is this? You know, if you really look at climate change and climate warming over the last 150 years, like really 1910 was a significant beginning point that began this upward trend. And we can argue with regards to how that story has played out and how that continues to happen, whether it's warming, cooling, the various forces. But what I'm really getting at is the origins of what drew me into this, what
Mhm.
kind of put me into this. And so as I began to look deeper into that particular period, I eventually stumbled upon this hypothesis that physicists had had since the mid 70s, that some of the very high powered, very low frequency transmitters used on a global scale for submarine communication networks were actually interacting with some of the particles up in the magnetospheric region and causing them to rain down in batches upon the upper atmosphere, reacting with the chemistry and causing a formation of nitric oxide, which then can deplete ozone. So there's been this hypothesis around since the mid 70s that there's a possibility of this, and so that's when I realized that there was this dynamic. I was like, whoa, hold on, I want to study this. I want to know, why is it that this is not a part of our conversation? Why isn't that? And so I ended up dedicating about 2 or 3 years to deep diving, collecting all the information I could to understand that, and that's what became the Broadcast Theory website.
Wow.
Yeah.
Okay. All right. So there's no climate deniers here, or they so-called say climate change deniers, because both of us understand that it's always changing no matter what,
Yes.
um, and that's always getting warmer or cooler.
There's always going to be natural variability. That's always going to be a factor. But the question is there an anthropogenic influence in that? Do they both play a role? I mean, there's always going to be natural variability. There's no question.
Right. So I really want to understand what it is that these Hissler and Whistler waves are, because these have recently come up on my map and the geometries that I work with. Dude, I don't know if you've looked much into some of the content that I've put out, but I've recently kind of stumbled on to this deep understanding of these helicon physics is what it's called apparently. And like, I haven't even gone deep into the math of it, but I'm intuitive, so I intuit this stuff. But it really mainly came from this one. I don't want to call it channeling, because it was more like, um, I don't know, the hand of God. Honestly, that literally was more like an accurate representation of what it was, the understanding of it, how I felt, and afterward these geometries came out of me. But this has been a long time since. It's been 17 years now, and I've gone deep into understanding each one of these maps. And I recently heard the sounds of the northern lights, and the sounds of these northern lights, um, if you could hear me out for a second, maybe it goes along with what you're talking about, because you and I both use. I saw a map that you use on your website, there's an image of vortices going up and down, and it's a painting.
Okay.
Do you know who paints that or painted that?
Oh,
I
I'm
don't
not
either.
specifically which one you're talking about.
Okay, I'll have to pull it up. I'll have to pull it up.
Okay. I think I do know which one you're
Like
talking about.
lightning
You-
and like
And there
tornadoes.
yeah, there's like a whirlpool, like whirl, like
Yes,
kind of cones
a
coming. Yeah,
bunch of them.
that was, I don't remember the specific artist, but that was a picture that was depicting the Jovian atmosphere of Jupiter. That's kind of what that was depicting.
Okay, okay.
It was the Jovian atmosphere of Jupiter is kind of what they were going for, and it's very similar in a lot of ways to our own magnetospheric and ionospheric system. In between the layers of the ionosphere, you have like the E layer, which is one of the most dense layers, and then you have the F layer up above that, which is higher, and then you have the D layer, which forms mostly during the day, lower than that. So in between the E and the F layers, you have all this energy, these dynamics that are going in between these two layers. And there's a low density region in between that where there's so much energy flux going on. There are radio waves, there are, lightning and just density fluctuations as solar wind comes in and brings energy in. It also creates a lot of plasma turbulence in that environment. And so when I began to like dive into like how do I even begin to wrap my head around like whether or not there's any like connection between radio waves and broadcast, I started by looking at how radio waves interact with the ionosphere, different frequencies, different layers. And what I learned is that the E layer of the ionosphere has its own natural frequency. It has a very natural frequency, and that frequency actually falls in the AM broadcast band. So
AM?
and in the AM broadcast band, yes. And so that frequency is called the gyro frequency. And it goes from about the range of the gyro frequency is about 630 kilohertz up to about 1630 kilohertz. So it's the medium is right around 1.45 megahertz, and that falls in the AM broadcast band. Now, the gyro frequency was first explored by Victor Albert Bailey. This was in the late 30s. He was
Victor Albert who?
Victor Albert Bailey.
Okay.
Yeah, he was an early radio scientist that was exploring how radio waves kind of interact with and bounce off of the ionosphere. And he found that there was this specific frequency that would actually cause the radio wave to almost like get sucked up by the ionosphere. The ionosphere absorbs it, is what happens. And at
It
that
induces
particular
it induces particular frequencies.
Yeah, what it does is when you hit that frequency, when you hit the ionosphere with its own resonant frequency, it turns the electromagnetic energy of the radio wave into kinetic plasma wave turbulence. So actually doesn't reflect the signal very well. And so in 1937, Victor Albert Bailey, V.A. Bailey, this became known as the Bailey effect, and he predicted that this gyro interaction would occur using only 1 to 2 kilowatts of energy. And what it would do is it would stimulate the ionosphere in a way that other very low frequency radio waves passing through that region of the ionosphere would get boosted up to 4 to 10 times, the signal would boost. And so this is kind of some of the early gyro interaction experiments that they did, zapping the ionosphere with its own resonant frequency. And what's really interesting is that in 1946, there was a set of experiments that experimentally verified that it only took 400 to 500 watts to stimulate this effect in the ionosphere. Now, this is on an AM broadcast band. What you have to understand with this is currently AM broadcast is limited at 50,000 watts. That's 100 times the amount required to stimulate this gyro interaction effect and to boost VLF signals. So there's a lot of really complicated but amazing dynamics going on up there. And really, we're still learning a lot. But yeah, so it's a profound region to explore for sure.
So do you think that helicon waves, since they sound so similar to uh, whales, uh, frogs, birds, living creatures on Earth, that there's some sort of a sound scaffolding that's happening and that's being built inside of these uh, uh, recurrent the waves of these helicon waves that are moving around in the Van Allen belts, because this is kind of where I'm going with my theory, because that's what I'm finding with the geometry I'm working with.
Yeah.
Like, I call it electrosonic speciation theory.
Oh.
Um, so like these sounds are in the heavens,
Right.
and there's a geometry to them, and they're Hissler and Whistler waves, and this geometry is very simple. It's first principle magnetohydrodynamic geometry.
Yeah.
And this geometry unfolds. It's very simple, and I show the Bessel functions of uh, how they come off of the sun. And I went and met with Donald Scott, and he talks about these being Birkeland currents, and my geometry is as if you were to be standing in a Birkeland current, and you could see all of the intricate detail. That's what he said. I gave him the geometry with no words, and he put words to it. And this is the guy who wrote the book on electric sun.
Oh yeah.
So like I'm really interested to try to tie our work together,
Right.
understand more of your work, so that because you're speaking my language and
Right.
I'm understanding what you're laying down. Now I'm seeing this happening on a soul scale, with souls and soul dynamic going up and down, streaming and beaming at the same time.
Sure.
Like that image conjures so much the image of the Jupiter vortices.
Yeah.
It conjures so many different uh, ideas that uh, it has personally something special to do with me. I posted it, and then someone passed away, and I was like, "What the heck?" So I took it off my thing, and then I posted it again, and then someone passed away, and I was like, "Well, what's going on with this?" So I had, and then I seen it on your page, but that's something that's neither here nor there. It's more like the this could be a direction, like a sign or a symbol or whatever. And I try to keep this stuff as far away from the reality of my life as possible, because this is kind of conjecture and can be like, oh, these life experiences. But no, this is how I operate. So this is how I talk, and this is how I relate to people, um, many times. So so if our infrastructure is what's really creating some of these beams that are coming down, these DEWs, these directed energy weapons, which I
Mhm.
saw some of your presentation talking about, right?
Right. Yeah. Yeah.
I want to kind of direct us towards that direction, but I also want, I never got to ask the, I guess we can get back into the life forming, maybe let that kind of move around in your head and we'll get into the directed energy weapons.
Right.
But yeah, just maybe think about how the sound scaffolding could work from these nested tube torus
Right.
of the Van Allen belts and really propagate and choose
Mhm.
what life lives and what life dies, because we often talk about life that's going out of existence, going extinct, but we don't really talk about life that's coming into existence,
Mhm.
like new creatures all the time thriving around the center of the equator.
Yeah.
So go ahead. That was a couple things. Just go ahead and pick there.
Yeah, so I guess where I can see there being some interesting crossover is especially when you're talking about sound in the ionosphere and magnetospheric system. One place that there is interesting crossover is I was talking about the E layer of the ionosphere, one of the more dense regions of the ionosphere. Um, Within the E layer, along magnetic field lines, there are these naturally forming ducts that happen, long tubes. And what can happen is when those tubes get charged or affected by radio waves and also by precipitating electrons, a lot of different things can cause those tubes to charge. But when that happens, pressure waves will affect that tube. And because they're low density tubes, they actually generate what are called ion acoustic waves. Now, ion acoustic waves are a form of sound waves that are traveling through the ionosphere. Those tubes can charge and begin spiraling the energy around the tubes. And any ions, particularly oxygen, you'll find a lot of oxygen, the element of life. Those
Inside of the E
molecules
layer.
in the E layer, yeah,
Yeah.
there are tubes in there, and these ions will spiral and go long distances through these tubes. And so what they found is that using the HARP scientific transmitter is that when they were exploring the different frequency range, that just above the ionosphere's natural frequency, just like the top layer of the ionosphere, they would zap it and they would cause these ions to go flowing as traveling ionospheric disturbances toward the polar regions. And then they would cause ion outflows to come pouring into the polar cap region. So they would zap the ionosphere with the HARP transmitter, and ions would come flowing out into the polar region. Now, the interesting thing with that is that there are already a natural amount of ions flowing into the polar cap region. But the trick is that we don't actually know what natural is, because our ability to measure these things, this phenomena, has been born in the sound of our anthropogenic noise, our radio noise. So we don't actually know like what natural is. And so we don't know how to parse apart what is natural and what is being contributing to that on an anthropogenic level. Now, when
So,
you're thinking of
so if those exist in the E layer, is the E layer in the Van Allen belts, or is that still in the atmosphere?
so that's still in the ionosphere, which is lower than the magnetosphere. The
And that's what we
magnetosphere
bounce,
comes out of the
and
north.
that's what we bounce the frequencies off of, the E layer, right? The and
Uh,
we how we have broadcast.
Yeah, depending on your frequency, it will bounce off the E layer, or it will go through the E sometimes and bounce off the higher F layer if it's a higher
Okay.
frequency.
Yep, like you
And
were
if
saying.
it's higher than that, it'll go straight through the F layer too. Um, the very low frequency waves, what those can do is typically they will bounce in between the ionosphere and the Earth. But depending on where they're located, if sometimes those signals will get ducted through the magnetosphere. So just as there are naturally forming ducts in the ionosphere, say in the E layer, there are also ducts that happen in the magnetosphere as it comes way out of the North Pole, circling around the planet and into the South Pole. Um, Now, what happens is those very low frequency waves can create whistlers. These are a plasma wave that form inside these ducts, and they will
Yeah,
bounce all the way up and down inside these ducts. Now, Whistler waves were originally discovered during World War One, and they were misidentified as falling bombs. The very low frequency radio operators heard these like pew, boo, and they were like, "Whoa, there are bombs going off. This is crazy." And so, and now we know that it's actually these plasma waves that are zipping back and forth through the magnetosphere. And Whistler mode waves are created primarily by lightning. Lightning is a big source of Whistler mode waves.
yes.
Very low frequency transmitters are also sources of Whistler waves, and power grids, power line harmonic radiation. So our power grids also give off a radiation that stimulates these Whistler mode ionospheric plasma waves to go zipping through the ionosphere and the magnetospheric system. There's actually a whole bunch of these that the Demeter satellite that was originally created, it was created out of France. The French National Space Agency created the Demeter satellite. It's a microsatellite that measures anthropogenic and natural radio frequency. Wonderful satellite. That satellite just blew our minds with what the data came back, and it's continuing to provide a lot of wonderful information. But I digress. Um, that satellite showed that there were a lot of Whistler mode waves coming off of the power grid along the West Coast. Now, those Whistler mode waves were actually launching off the West Coast through the ionosphere, through the magnetosphere, across the equator to the middle of the South Pacific Ocean, and they would bounce back. Now, I'm getting to the do's that you were talking about.
Hmm.
So those Whistler mode waves can go bouncing back and forth in between where they're created from the West Coast power grid. They can go bouncing off the South Pacific and back again. These are called one hop, two hop echoes. As they kind of echo, the signal takes about 8 seconds. It's really quick. Like if you launch one off, 8 seconds back, boom, you'll hear the signal come right back at you. And that's gone all the way across the equator and back again. Um, so what's interesting is that when it's geomagnetically quiet, the ducts that form in the magnetosphere that those whistlers flow through become very coherent. They become very well formed.
Yeah,
And so the mode waves can flow through exceptionally well. They can bounce back and forth, and they can even amplify, self-amplify.
their bodies, they're living bodies. They are the living creatures on Earth. I believe every living creature has
Mhm.
a corresponding umbilical cord inside of the helicon mode waves, and the trivial mode piece waves that are the corresponding, coefficient of friction as they move through it.
Yeah, that's
Dude,
deep. beautiful. I love it.
Yeah, and these are like the spines, and I do the geometry of it. And this is literally like this is how I believe uh, they diatoms inside of brine channels form. Those
Oh, yeah.
gla- those glass bodies of the same geometries that we're seeing inside of Whistler modes
Right.
and inside of the geometry I do
Right.
are so this is like Darwin, scrap Darwin. This is energetic electric. It's the electric earth grid, you know, the yeah, there's a solar electric grid, there's the earth electric grid, and you know there's a galactic electric grid, and all of these are working in tangent with each other. And there's the largest deposit of copper right here in Keweenaw Peninsula in Michigan, and this wasn't formed from a volcano. They say it was from the oldest volcano on the earth. I heard this on an ad earlier, and I'm like, what is this junk? Like, no, this is from a storm. This is from those storms that we were looking at that are on other planets, or that we were talking about, sorry, of that image. Um, these types of multi-vortical storms and mesocycles and mesocyclones pull and create these veins, these electric veins that move throughout the telluric currents inside of the Earth, and create the elements that we're being brainwashed to say that we're stardust. No,
Mhm.
we're electric grid, baby. We're tied
Mhm.
right into the circuit. We're not stardust. We're not some explosion. We're not something uh, that things rarely impact each other. There's fields that keep things from touching, and but either way, this is an electric universe, and I want to understand this plasma type of life forms from a heavenly perspective, as on in heaven as it is on earth.
Mhm.
And so that's really frankly what I do. And really it's what you're doing too. You're talking about how these chords, these really uh which the geometry of these is so intense, because I think I've gone on deeper levels than what they found inside of the textbooks. And as a matter of fact, for sure, we can look at it and see that these are multi-nested fractal lattices that are crystalline in shape, and this is happening all the time. And we can create a storm. We can make rain. There are rainmakers. We breathe with the weather. This is deep stuff. And you were talking about dews, so get back into them dews.
Right. So I got into this. That is beautiful, by the way. I just want to say I love your perspective and the way you have such a beautiful passion about what you explore. That's
Thank you.
awesome. Yeah, totally. Um, what got me looking at dues was um, I was in a conversation with a friend, and he was talking about how these directed energy weapons were uh, were intentional lasers from satellites creating fires, and they were Dutch Stintz, who is also like an observational, you know, he's got some really interesting observations out there. Um, uh, he had been posting these uh, videos with regards to these infrared beam signatures that have been seen in the atmosphere
I was
um,
watching that, yeah, time.
using the GOES 16 satellite. And so I began to kind of think about this. And I guess in my mind, like using sky lasers to start fires is probably not the most efficient way to do it. Like, in all honesty, there's a lot better ways to do it that are probably far less detectable.
Right.
Uh, And so I began to like wonder, well, could there be another way? And having explored some of the upper atmospheric dynamics, and particular Whistler mode waves as I have, I recall coming across this picture years ago about this image where all these whistlers were coming off of the power grid of the West Coast, like I was mentioning. And so I had this question of like, is there a way that during geomagnetically quiet times, yeah,
I think you might sound better with the light off. I think it might be taking some of your, is it connected to your computer? There's a
it
little,
is
there's
like
a
let me
little
like
like there's a little sound thing that like when it turned off for a second, you have
better.
I don't know, you have to keep talking.
Okay, okay. Well, I'll
Sometimes
keep.
your voice is like, I don't know if you get the interference or if it's just me. Where are you coming out of right now? What state?
Oh, I'm coming out of Seattle right now.
Okay.
Yeah.
Okay. Yeah, it's because I feel like there's a time delay and I'm hearing some interference, but it might not be on the recording as you know, but I'm hearing it, you
Okay.
know. That's all.
All right.
I noticed that it stopped breaking up when your light turned off.
Uh, okay. I'll let this kind of chill out, and hopefully it'll kind of sound better with time. We'll kind of feel into it. So back to dues. So I began to like look at some of the what are the geomagnetic conditions during the time that these dews are being observed, and what time of day. There were a lot of these that he was posting that are happening right around sunset time, and that's a little bit of a clue. Like during sunset, there's a lot of interesting dynamics that are going on in the ionosphere, where the ionosphere, when it's not being ionized by the sun, it starts to bubble up. It starts to kind of rise up, and you get the formation of these large plasma bubbles in the ionosphere. And during that period, um, if it's really quiet and those ducts form really well, you can get Whistler mode self-amplification. And what happens is when those Whistler mode waves charge the tubes that they're flowing through, they can generate what are called a magnetospheric maser. A maser is like a microwave laser, essentially. So a laser is a beam of light, and a maser is a beam of microwaves. When the electromagnetic energy in the ionosphere gets chopped up to microwave lengths, and it can form these beams that come beaming back down into the atmosphere and literally potentially come right back down on top of the power grid. So it could be that it's the power grid itself that are generating this amplification process. And the more I began to research this, the more I began to find that magnetospheric masers, those specifically related to whistlers, are maybe far more prevalent in our atmosphere than we know. And over the last 45 years, our ionosphere has dropped 3 kilometers. It has actually dropped closer to the Earth over the last 40 years. Yes,
Oh, nice.
the
Over how many years?
over the last 45 years.
All right. You
Yeah,
know, that's really important. I
yeah, it is.
because what I heard, if I could just say something real quick in between here, is that when the ionosphere comes closer to the Earth, there's um, possibly the rocks start making sounds. The rocks start
Mm,
calling out, and they start glowing at the tops and at the tips of the mountains and in different places, um, known as St. Elmo's fire.
mm-hmm.
Um,
Yeah.
but it comes on a massive scale, and Like this is where this is the origin of dragons and where plasma comes from, you know.
Yeah.
That's what I hear. So that's happening, you're saying, and it's going to continue to happen, you think?
Well, it's hard to, I'll be honest with you. I generally am of the mind that humans suck at prediction. This is, we kind of suck at it. Like, for all best intents purposes, like we do what we can, but we kind of suck at predicting stuff. Um, so whether or not that's going to continue or not is hard to say.
Hmm.
But as the ionosphere does come closer to Earth, there have also been a lot of other atmospheric layers that have followed suit. And as the ionosphere comes closer to Earth, I think we're likely to see an increase in space weather affecting lower weather dynamics. So you're going to see an increase in that connection, and more space weather is going to be affecting tropospheric thunderstorms dynamics that are lower in our overall atmosphere. Um, yeah, so, and I think, like, I kind of want to pull in this one piece regarding dews. It's really important. Um, is that I think it's worth considering that as the ionosphere has gotten lower, that it's possible that the very low frequency transmitter that's just north of Seattle, where I am actually, in Arlington, that particular transmitter, it's a very powerful one, and maybe increasing the ionospheric currents along the west coast that are causing the power line harmonic radiation to increase the amount of Whistler mode amplification that's occurring. Um, there's oh man, I could go on for so long with regard to some of that
So
stuff, but
so do you think there's constructive and destructive Whistler mode amplifications inside of these tubular ventricles? I mean, this is
yes,
all ventricle like. I mean, this is
yeah,
crazy.
yeah. There's what's called the dawn chorus Whistler mode activity, and that happens on
Which
the dawn.
chorus?
It's called a dawn chorus. It
Okay.
happens dawn in the morning time.
That's what I was just about. Oh my God, did I
Right.
hit the nail on the head? Oh my gosh.
So
Okay.
during the morning time, there's this chirpy sound that happens in the upper ionosphere magnetospheric system. It's called the dawn chorus because it sounds like a chorus of birds that
Yes.
happen. Those are Whistler mode waves that are dancing around up there.
Yes.
Now, now what they've found, there was research that came out just this year that's showing that the very low frequency transmitters are actually suppressing the dawn chorus. So there's so much interaction that's going on up there. And my question, what I really want to know is, we have been considering that a lot of scientists see the dawn chorus as purely a natural phenomenon. And I don't doubt that there is natural aspect and variation to that. But what I'm curious about is, right in the morning, all the AM stations that have been lower power at night increase their power. That happens also right in the morning sector. So what I'm wondering is, are the increasing power of the AM stations contributing to the dawn chorus? And then the very low frequency transmitters could actually be causing a suppression of that. So there's a lot of possible interplay of dynamics that are happening. When you look back at our climate history during the early 20th century warming period, that's a very unique period with regards to our historic use of broadcast frequencies. We were experimenting with AM broadcast. There was some low frequency and very low frequency transmitters, but a lot of the high powered stuff used for submarine networks didn't come in till after the 1940s. So during that time period, is a really unique time. And I think that there's a possibility that some of the AM broadcast could have been contributing to the climate warming of that period. And then as things went further on in our climate,
Cascade
uh,
was created.
what's that?
Sorry to interrupt, but a trophic cascade was created where it
Yeah.
just where it just built on itself.
Yeah. Yeah. I think so. I think there's a lot of like competing dynamics, because above the very low frequency transmitters in the ionosphere, there forms a hole. There's a hole in the ionosphere that allows medium frequency signals like those from lightning and those from AM broadcasts to slip through that hole. The very low frequency transmitters will amplify those, and they will escape and leak into the upper magnetospheric system. So there are holes that are formed in the ionosphere above these very low frequency transmitters. If you turn off a very low frequency transmitter, those medium frequencies that are slipping and escaping through those holes to the upper magnetosphere now get blocked off and begin to bounce back down in the Earth ionosphere waveguide. So there's a lot of different interplay of dynamics that are happening. But over the course of our climate history, there are two major arguable hiatuses in global temperature increase. One was right at the end of the early 20th century warming period, 1945, 46, which ended in one of the largest winters called the Great Winter of 1946 and 47. That was a significant decrease in temperature through in our climate history, and the other is argued to be around 1998. Now, there was another kind of hiatus, a little bit of a hiatus, arguably. People argue about this in our global temperature. When I looked at the very low frequency transmitters and their decommissioning, the highest years of decommissioned very low frequency transmitters were 1945 and 46 and 1998. Those two saw the largest decrease of very low frequency transmitters used on a global scale. So keep in mind, those are now holes in the ionosphere that are closed up. So AM broadcast can't slip out and potentially aggravate upper atmospheric particle fluctuation dynamics. So there's a lot in there. It's hard to break it all down, but I kind of do my best. I hope it makes sense.
No, it makes a lot of sense, and it really builds the culture, literally, of EMF. Excuse me, electromagnetic frequencies, because we don't think of them as layers, as meniscus layers, as surface tension, as I guess really barriers. There's so much more that I think this whole entire, like, I have a million questions, and
Me
I'm not
too.
sure how much time you have. I'm not sure how much time you have this evening, but we can definitely bounce questions back and forth, like these Whistler mode plasmas.
Yeah.
And I have a bunch of images of these Whistler mode plasmas and a bunch of other geometries. This might just make perfect sense in your head. I mean, it is a broadcast, and it's a network of a system. Uh, but I guess mainly I'm interested in a whole bunch of stuff, but when you were describing part of these loops and these layers, it reminded me of Alphane waves.
Yeah.
Um, and is that what they are? Are they Alphane waves?
Yeah.
Longitudinal Alphane waves inside of the of
Yeah.
it
Yeah.
is okay.
Alphane waves basically can split off. They can split off into Whistler mode waves. They can also split off into what are called electromagnetic ion cyclotron waves.
Oh, dude, fuck yeah.
Yeah.
Okay, see, now, we needed to have this conversation. Like this is, dude, we need to. Hopefully, you're available to have more time to spend with me, and we can get down to some of these layers of what this is,
Yeah.
because I have some real uh, substantive geometry that you can both measure, quantitative and qualitative geometry that you can actually measure and see what the heck this stuff is. And
Mhm.
I'm trying to find someone who's as passionate and driven in some way as to get down to the bottom of this, because
Mhm.
I feel like I'm alone in this echo chamber, but it's not an echo chamber. It's like these are echoic chambers. We are echoic chambers. Everything is part of this umbilical type of nature, and I'm really getting down and dirty into this with many different individuals. And thank you for getting down and dirty with me on frickin' and this the electric universe geometry. How much time do you have this evening? We're about almost an hour in.
Yeah.
Um, so
I
what do
have
you?
allotted plenty of time.
Okay,
I was really excited about this, and I just kind of wanted to let us have playtime
nice,
to just
good,
whatever we wanted to talk about. So I
cool.
can do another hour if we want. That's good.
All right. Yeah,
Yeah.
that's about what so far they're around 2 hours, which is better than my other show. They're my other show, they're on like 3 or 4 hours. And that's coming from the electric view, which is an even longer show.
Yeah.
I've been doing this since around 2017, and I started the electric view with Neil Thompson. And I'm not sure if you've heard of that, but
Mhm.
the electric view, it's a bunch of I actually asked Rick to be on here because he would definitely help be able to spark uh, some of
Mhm.
the vibrance to the knowledge of the conversation here. But you and I are great here for trying to understand what this really is. And I've been making sculptures. I've three-dimensionally constructed these nested uh, uh, helicon waves, which when I say helicon waves, I use it interchangeably with um,
Yeah.
Whistler mode waves, because I guess they say they're the same. And then all of it together is what? Helicon physics? Is that it?
Yeah. I mean,
I mean,
that's the
I don't know.
spiraling geometry. Yeah. Yeah, for sure. And I've seen some of the pieces that you've made. They're really beautiful.
Thank
Yeah.
you.
Yeah, totally.
Now this is super strange and weird, but it's like a fabric that's created, like uh, a network, a lattice, a fractal stacking grid of spherics,
Yeah.
and spherics are the sound the geometry of lightning and spheres, right? What is it? What is spherics exactly?
Well, spherics typically refers to the plasma waves generated from lightning, which is Whistler mode waves. So
Yeah,
that's what they're called. Like when they're actually listening in very low frequency receivers, they hear what they call spherics, and those are the Whistler mode waves propagating along magnetic field lines in various density tubes.
and there's
Yeah.
nutrition to the thunder.
Mm,
The nutrition of thunder is something that I've been really focusing on. And I
mm,
think my mic is there. That's much better.
mm,
Um, the nutrition of thunder is just like something that I've been vehemently chasing down, because I think that the fear inside of thunder is meant to make certain creatures do certain things.
mm,
Not only the fear of thunder, but also the smell of rain,
mhm.
which is petrichor. The name of the smell of rain is petrichor. Um, and I'm glad. Did you know that?
I
A
have heard
lot
that.
of people,
Yes,
that's
I
good.
did.
Yeah, a lot of people. Some people don't. It's becoming more popular, but these things that are real, that are tangible, that are they're visceral. They make you feel a certain way. Like there's only certain stuff in nature that'll make you feel a certain way. But the more you search, the more you'll be led by beauty.
Mm,
And as beauty guides you through your affinities, your natural attractions to things, you'll understand more. And that's how I found my life, um, going, at least. But the I'm really, really focused on something that I've called uh, the hydroelectromycelial network,
mm,
and I think that if there's not a name for this yet, there needs to be, because it's a real thing, and that's the end of life and the beginning of life, and they begin and end with Hissler and Whistler modalities,
mm,
and they go inside of mycelial Lichtenberg type fractal patterns of the same type of patterns as lightning, same type of patterns as our
mm,
guts, same type of patterns as our brain, neural synapses. This is an electric record being recorded all the time, and the geometry I'm working on is the tree of this bifurcation, and the fractal lattice grid, and there's an infinite amount of them, and I'm just super excited for people to start getting into playing with it, because that's what we're doing. We're playing in a sandbox here, and we're speaking the same language. So when people, like the kids of the future, start picking this up, because I mean, I'm writing kids books. I don't know about you, but definitely lots of children's books, because that's what this stuff. If you can't reach the kids, then you're not reaching anybody, and that's what the future is.
yeah.
It's so simple for them to see and understand that why is God, the sky god of almost all religions around the world, the God of all gods, the God above all gods, the God of gods, because we see this trickle down, top down, matricy, this hierarchical effect, and we know that we are transceivers. We make the thunderstorms. We breathe in. As a tribe angers, stuff happens. When sacrifices happen, things happen with the weather. Things are connected.
Yeah. Yeah, there's definitely an anthropogenic, like, yeah, connection there. Some of it's the way you kind of describe it is like this beautiful, like, poetic form of anthropomorphism.
It
It's
is.
kind of like this, and that's so, like beautiful, and I really
Well,
appreciate
I've
that.
experienced it. It's not just beautiful.
Yeah,
Seriously,
yeah,
I've been deep into the circuit many times, and
yeah.
I do high voltage electricity. Um,
Mhm.
I do electropyrography, which is turning
Oh,
high voltage electricity through wood as it fractal as it branches through the wood. A lot of people have seen stuff like that, but I was part of the movement that popularized this, and since then, lots of people have died because they don't know what they're doing. I still don't know what I'm doing. I'm a lucky one to survive, but I warn people not to mess around with this high voltage electricity. But when you do, you get to hear what it wants, what the circuit needs to complete itself.
mm,
what it desires, just the right amount of water, just the right amount of saturation, because it becomes quiet. If
Mhm.
there's no water, if there's no membrane for it to work on, it becomes dead, silent.
Hmm.
And then as soon as there's a little bit of saturation, it becomes alive again and can start completing the loop.
Yeah.
And these geometries are the only reason I kept doing it. At the time, there was no science of this, and there probably still isn't a science of how much radiation I'm getting. My feet started hurting, and I was doing a lot of the work by my feet, so I thought I was getting electric radiation from working with the microwave, because it's a Tesla coil. Ultimately, it's just your transformer from a microwave, and
Mhm.
then I rewire it. So it's low amperage, high voltage, and you know, you can die from it if you do the wrong thing. And I've almost grabbed the two cords, the two leads at the same time.
Don't die. Don't die,
But
buddy.
this is the circuit. I mean, this is the dragon. I'm talking, we're going straight into it and trying to understand what is the geometry of lightning. Why does the grid create um, create resonance of these 8-minute feed or 8-second feedback loops like you're talking about on the LA grid?
Mhm.
This is nuts, dude. I don't hear anybody talking about this stuff.
Yeah, it's been a passion to kind of research and just dive in to the science of it, to connect some of these things that we're seeing with, with the science. I just,
Why aren't
the
people
I
making a bigger deal
I
about it?
what?
Why aren't people making a bigger deal about it? Like
Well,
it's like
I
old stuff
think
from the 90s.
I think there's a gap in communication in a way, because the scientists that study these upper atmospheric dynamics and have the ability to understand these things, on a technical level, they are bound to the scientific method, and that's their tool. And so their tool and their job is to develop hypotheses and to find ways to test those hypotheses. Their job isn't to tell the public what's going on. That their job is to develop hypotheses and find experiments for those. So like unless you are accustomed to looking through scientific journals and poring over them and reading them, then there's a big gap in between like the public's knowledge with regards to some of these new cutting edge discoveries
Right.
and some of the that they're studying.
Well, look,
So, there's
I guess, I mean, you can sorry to interject again, but I mean, I guess you can look at fractal patterns and how long it took for fractal patterns to catch on. And like
yeah,
I was talking about fractal patterns in 2002, 2001, 2003, 2004. Nobody knew what I was talking about.
yeah,
And it was like the internet wasn't around. I was like, just like, oh my gosh, like, oh man, going off in the universe, just
yeah.
understanding what fractals are and how it's so similar to a LSD trip and how they came out simultaneously at the same time, you
Mhm,
know, and how convenient that was. But Benoit Mandelbrot, he didn't do any acid, no LSD for him. Uh,
mhm,
it was just an iteration of the reiteration of a Julia set. So when you take fractals and you take the mathematics of this and you break it down into cylindrical channels, uh, you get the literally the same thing that's happening on a cellular level. We are antennas, and our consciousness taps into these brine channels inside of this salt water crystal grid that the earth is. um as a transceiver, the earth is literally pulling the heavens down into the grid, manifesting the grid on Earth, and then re-manifesting it. The wolves are working with lightning and the spherics because they hear the auroras better than us. This is how they can shape the river. This is what the trophic cascade is. See, all of this comes down to like, because man, believe me, like I can't wait to understand more of how our understanding comes together, because I just came across this whole thing as I started presenting my material, and as I keep presenting my material, more material saturates the material and makes it more dense, because as it already is the master grid of electromagnetic induction, and that's what I'm finding. I keep the Bessel function of this is displaying. So we're going literally into this geometry and into these tubes, and tell us more about these tubes, because I don't know anything about them.
Yeah, well, yeah, they were first kind of explored, well, with Victor Herbert Bailey and some of those early researchers. That's when they were kind of realizing that the gyro frequency would cause this plasma wave turbulence to go through the tubes. Yeah, so I think that you know, it's yeah, it's modernly, like, it's known as the gyro line,
Okay.
which is like when some of the transmitters that they use to explore, the scientific transmitters that they use to explore the subtle dynamics of the ionosphere, are called incoherent scattering radar. So they'll kind of bounce high frequency signals off of these tubes to kind of see how, pick up the signal and see how those tubes are reacting, like, to various stimulus. If a solar wind is increasing, or a coronal mass ejection, or solar proton event brings energy into our system, and an energetic electron precipitation happens. These raining electrons scatter along these tubes and kind of stimulate these electromagnetic ion cyclotron waves, the ion acoustic waves, in such a way these can actually, like, form relativistic beams. So they can actually have these beams that form, going really long distances to these tubes. And yeah, it's amazing. Like, it's an amazing, just cacophony of sound and energy that's dancing above us. It's really pretty amazing, but it's also hard to pull it apart,
Yeah.
and I think that's another part of, like, when we were talking about, like, where is the gap in communication, like, some of that happens because some of the things going on up there are so complicated, like energetic electron precipitation, as the electrons raining down. They can be caused by very low frequency transmitters, but they are also caused by solar energy coming down. So, so being able to pull apart that signal and tell what's natural, what's anthropogenic, is a very difficult thing to do. There was an experiment done in Australia using the largest VLF transmitter in the world, called the Northwest Cape transmitter in Australia, where they use satellite observations to see the electron flux above the transmitter as the transmitter is turned on and off, on and off. And they found that transmitter in particular was creating about 430 times above background levels of medium energy electron precipitation. Now, separately, this medium energy electron precipitation was used by included in some of the most recent climate models, the CMIP6 climate model of mesospheric ozone. And with the inclusion of medium energy electron precipitation, they saw a fluctuation of about 20% of regional ozone depletion occur with medium energy electron precipitation. So when you look at the fact that this Northwest Cape VLF transmitter can create 430 times more of this medium energy electron precipitation, and you're seeing these climate models running simulations that polar mesospheric ozone depletion can occur with that same energy of electron precipitation, we got to begin wondering, is there a way that these things are connected? Is there a way that some of these very large, high-powered transmitters can stimulate some of this ozone depletion in the upper atmosphere? That,
Now, for as far as ozone depletion, is I heard that it's repleted every day, if not more than the
oh
amount
yeah,
that it needs to, right? So it's not
oh
a
yeah,
problem, but like we like to use
yeah.
it as a problem, like so we can tax people, right?
Well, there's the replenishment of ozone in the atmosphere is called the Chapman cycle. That's where UV light comes in and reacts with the molecules of the atmosphere to replenish the ozone. That is a natural cycle. The thing is, though, is if you have a constant process that chews on the ozone layer, then it's not going to be able to replenish itself to its full capacity. So if there is an anthropogenic component to ozone depletion, then it won't be able to replenish itself fully. So although, yes, there is that natural cycle,
Is
just
that
chewing
still a
at it,
problem? Is that still the ozone depletion still a problem?
it actually is. Like, actually, in February of this year, we saw the lowest ozone levels in the historic record. And the Montreal Protocol that was actually set in place to ban CFCs, which are believed as the premier cause of ozone depletion, anthropogenically speaking, is now being called into question. So there are scientists. There was a paper that came out this year, the reappraisal of the Montreal Protocol, because in that scientific modeling of ozone depleting substances, um, they found that the ozone depleting substances using their model wasn't having the same significance on ozone that they had previously thought. So it's now calling into question that the Montreal Protocol might not have actually been as beneficial to the ozone layer as we previously thought. There's another paper that came out just last year that's saying exactly the same thing, that we're seeing the lower stratospheric ozone layers, and that's lower stratosphere is where most of the ozone layer is seeing a continued decline. Even though you're seeing upper stratospheric like increases a little bit here and there, the lower where most of it is still declining. It's declining over populated cities. An ozone hole opened up over South Africa. You're seeing equatorial ozone depletion. You're still seeing like a certain amount of ozone depletion. And the problem with that is that as your ozone layer depletes, it allows more solar UV radiation to come in, reflect off the planet, increasing long wave radiation that's then heating the surface. the atmosphere, gases in the atmosphere. A lot of different questions with regards to how all these dynamics are interplaying. But ozone depletion has now been verified as the primary cause of climate change in the southern hemisphere. All right. Scientific research is coming out showing that ozone is the primary driver of climate change in the southern hemisphere. This is kind of a big thing. This is only last year, 2019. Before that, they didn't think ozone was that big of a deal. But now there's this like big wave where, hey, wait a minute, we're actually beginning to think that ozone plays a larger role. You won't hear about a lot of the questioning of the Montreal Protocol in the news. You won't hear about that. But if you actually dive into the scientific research, and I can share with you, I can share with you these research papers where scientists are really starting to go, well, wait a minute, we're seeing record levels of ozone depletion on regional level, and yet ozone depleting substances are now being modeled as being less effective than ever. So what's causing the ozone depletion? And what I'm suggesting is that it might actually be transmitter-induced ozone depletion. It's Dr. Allison James. Dr. Allison James came out and did a presentation on cutting edge radiation belt research at the National Academy of Sciences 2018. She used some of my presentation material on transmitter-induced ozone depletion in her presentation. We had some great conversation afterwards discussing some of the upper dynamics. But she says that, in that presentation, that ozone depletion from energetic electron precipitation, if energetic enough, can have long-term impacts on weather and climate. So this is a new cutting-edge information that's coming out that's overturning the old idea that ozone doesn't play a role. When some people will come at me from climate, groups and stuff, and they'll say, oh, that was overturned a long time ago. And I'm like, no, this is very new research that's coming out. There's no, it's very new, like in the last 2 years, so there's a lot of really interesting information that's overturning that old idea, and we're finding more and more that there's more to it than that. Yeah.
Well, honestly, I think the E layer is blowing my mind, and I have some stuff that I could show off, and I know you might have some stuff that you could show off. So let's have you show your screen if you have some content that you're ready to show. If you don't, I have some content. If you know how to share, and if you've been on Skype yet. A lot of the guests don't know how to navigate Skype just yet, so I don't want to put you right on the spot there.
Let me see if I can pull something up real quick. Yeah, I do have some lovely stuff I would like to share. And let me just see how I can do this. I think I can figure this out pretty quick here. And yeah, there's something I would like to pull in. Let me just draw this up here. Come on.
And I have a question about cyclotron waves. Are those the waves that that the CIA are using to propagate directed beams into our ears? Because I tied together.
Right.
Also, the stuff I tied together, you're confirming, and I fucking love it, dude. I'm super stoked about this episode because, like, I had no idea about any of this stuff, and like, I'm just like putting things together, just like grasping at straws, and like, I'm like, yeah, hammering them down because this is it, man. This keeps going, and it's just gonna keep getting deeper and deeper. There's beautiful geometries here. So
Yeah. So, well, the thing about the thing about my research in particular is that I'm very specific in that I study transmitter-induced ozone depletion very specifically.
oh,
I don't get into a lot of the biological effects of various frequency waves. Um, I think that there's a lot to look at, and there are a lot of people with input on that. The reason why I stay really focused on transmitter-induced ozone depletion is because there's 5 decades of peer-reviewed research on the matter, and that's what I really want to get out to the public. And I
okay.
don't want to muddle my message with a lot of other things because it's complicated. I mean, I try to tell people that I'm not necessarily a clearinghouse for all things related to radio frequencies and
Oh no,
biology and birds, but so I'm pretty focused on that dynamic specifically, but that's really fascinating research all the same. Yeah.
yeah, you've been blowing my mind so far this whole time, man, and I've been just barely dipping my toes in, and the deeper I dip my toes in, the more words you're talking is the language that I'm speaking. So I'm moving in a certain direction, and I see my vector, and I'm like, wow, I see how much it relates, and I just love this. The gyro line, Victor Bailey and the Dawn chorus and all these things that I didn't know that like I was just about to ask you, what about dawn? What about like because you expressed so eloquently like when at dusk, like a sunset.
Yeah.
I want you to express like the opposite of that, like dawn. I was just about to
Right.
ask, and then you were already hinting towards dawn chorus.
Right. Yeah. Oh, here, let
So
me.
what is that? Is that like a coming down instead of going up? And like,
It
because
is.
Jesus said that's the best time to pray or whatever, I'm sure other prophets did too. And maybe, that's the witching hour. And like from 3 to 6, there's this energy inside of, if you study, uh, uh, structured water, I can
Yeah.
never, Gerald Pollack and structured water, you'll
Hmm.
see that water has a structure to it as it changes its phases. Every time it changes its phase, it gets this hexagonal structure to it. And I think that this is the same kind of thing that's happening here with these helicon waves and our larger membrane of our uh, anthropomorphic membrane that you kind of brought up.
Yeah. Well, it's really interesting. The dawn and dusk region of our ionosphere is a really fascinating area, specifically because during the daytime, when the solar UV ionizes the atmosphere and the ionosphere, it causes it to kind of like hug the planet really closely. Um, so right as dawn, and there's so much, it's beautiful. I love like some of the imagery where in at dawn, what's happening is the sun's rays is kind of curling around the planet, and it's causing the ionosphere that at nighttime is very high and bubbly. It's now causing it to sink down and hug the planet. But this is a wave of ionospheric alteration that happens as the whole as the planets move. And so the angle of the ionosphere is a really important thing with regards to how radio waves impact the dawn chorus, because the angle will change. And there was a meeting in 1996, a meeting about Whistler mode waves. And if you're really interested, I can send you some information on this. It was a part of the International Radio Union, a group a subsection called VERSEN, VLF, ELF, remote sensing of ionospheres and magnetospheres is what it's called. And they were talking specifically about Whistler mode waves in the ionosphere and magnetospheric system, and how the angle is really important. So I think when we look at some of the radio wave interactions with regards to AM broadcast and VLF broadcast, incorporating some of the angles that are generated in these particular dawn and dusk sectors is really important. What I would love to see, this is just my dream, is that I would like to see us begin to reevaluate the AM broadcast band with regards to not only its effects on reception and signal quality, which has caused its limitation to a certain degree in the past, but I would really like to see a deeper, richer understanding of how AM broadcast may be affecting what we consider natural phenomena like dawn chorus, and have a reevaluation and see if there might actually be some anthropogenic influences, because it could be that if there is, we could radically shift and alter some of these dynamics up there. You know, like in 2017, these scientists got together and they speculated of how they could terraform Mars, for example. And they came up with this idea where they could actually generate a magnetic field, a shield that would actually block solar wind particles coming from the sun and block some of the Martian atmosphere, allowing it to rebound. Well, the interesting thing
Was that
is
by
that
a nuke?
You mean the
By nuke
no,
Mars?
it's actually not by nuke. They were actually looking at they had a couple different ideas, but one of them was using a kind of like, I think it was like a reactor engine kind of thing that's actually not on the planet, but it's up the solar wind, and it would generate a shield there that would then kind of block the solar wind in a way, so that it wouldn't hit the Martian atmosphere so intensely. But the interesting thing is that in 2017, NASA has a web page and a video talking about how we have now created a VLF electromagnetic bubble around the entire planet that can block solar particles. This
Of
is huge.
Earth?
It surrounded Earth. Like, we've created an electromagnetic bubble. The scientists call it an impenetrable barrier, which is a loose term, but it is a region in the inner magnetosphere, right near the in-between edge, where higher energy particles, electrons and protons coming in, actually hit this barrier created by the ground-based VLF transmitters. They hit the electromagnetic bubble created by all the VLF transmitters on the surface of the planet, and it decelerates them. And so you actually don't see any of the higher energy particles coming within the shield that these VLF transmitters are creating. This is freaking terraforming technology. This is terraforming technology. If we realize the full potential of this, we can use this on other worlds to generate shields around other planets, possibly, blocking solar energy from local stars and transforming the atmospheres of these planets. This is terraforming technology. Once we really wrap our heads around it, there's a lot to explore with that. Yeah. Sorry, I think I got digressed there. I get excited about
fun, though.
because it's to mind, but
terraforming Mars is a good topic. I mean, I think of it like a sort of like an Oort cloud. Like if you can build a cloud that's in constant communication with the center of the mass, then you can build up that as a fractal array and have it constantly communicating with its outer layers. And each one of them we can just replicate as our own atmosphere and troposphere and ionosphere. If we know those frequencies and the different types of elements that are there, we can try to bombard it and try to, if you simulate the environment, it'd be hard, man. It doesn't even have a moon.
yeah, no, I agree. I mean, I think it's a tough cookie to crack when it comes to Mars.
Got a bunch of little
I
moons,
think that
nothing big.
somebody was saying that there's actually one of the moons of Jupiter might even be better. Was it Europa? I don't recall specifically.
Europa.
But I think the idea in general is that, it could be used as terraforming technology. And the important takeaway from that is that if we can use this as terraforming technology, anthropogenically affecting climate dynamics on other planets, then there's a chance that we could already be doing it on our own planet. And if we do that not unwittingly, but intentionally, and realize the effect that we may already be having, then we can begin to I mean, imagine that. If you could switch a dial on all the VLF transmitters on the planet
What
and change the thickness of the ozone layer, that's mind blowing. If
what
you
are
could actually
what are the
change,
BLF transmitters exactly? They're everywhere, but what are they? Where are they? What is it?
well, the very low frequency transmitters, they're the high powered ones. They're actually, they're not a lot of them. Like there's maybe like of the major high powered ones, like big time, there's probably definitely less than a dozen like on the planet. I mean, sure, you have a lot of like smaller ones, but the actual large behemoth ones that are used for submarine communications, there's three across the United States. There's one north of Seattle. There's one in North Dakota. There's another one in Cutler, Maine. Those are the three biggies. And then there's another one, NPM, over in Hawaii.
Okay.
And then there's three of them in Europe.
Yeah, I wish I knew this at the beginning. Like, I wish I would have asked this at the beginning. I wanted to ask it, but like for the viewers, like because I'm not exactly sure what these are and what they do, and this is your whole big. This is it. Your transmitter-induced ozone depletion
Yeah.
comes from these very large frequency transformers, right? Or these
Well,
transmitters.
in a sense, there's a good question around that. But I think it's a little more complicated than that because there is a chance that these large transmitters do play a role to some degree, but knowing what that is complicated because it could be that they open up holes in the ionosphere for other radio waves to be magnified and stimulate higher energy ozone depletion. So there could be an interplay. It's really complicated, but yes, the thing is that the the long wavelength used by these very low frequency transmitters to penetrate the seawater to communicate with the submarines under the water also make it out to the magnetosphere and affect those particle populations. And so there is some kind of interaction there. But the questions that we have around that are that the very low frequency induced electron precipitation happen at a higher altitude in the polar ionosphere, for example. Again, this is kind of complicated, but some of the higher energy electrons that come from solar proton events that penetrate deeper into the atmosphere get blocked by aspects of the VLF transmitter-induced bubble that surround the planet. So we haven't fully figured out all the acceleration and loss mechanisms with regards to some of these energetic electron precipitation. There was a report that came out last year from the Russian scientists that said that what we have considered the natural energetic electron precipitation signal, they're now seeing that there is a trend in that what they've considered the solar signal that doesn't match any solar or geomagnetic activity. And they state plainly that it could be from ground-based VLF transmitters that this trend in the solar signal is observed. Now that is huge, because that actually begins to imply that there could be some connection between ground-based transmitters on Earth and solar activity. That's kind of a huge thing. And that's an extended part of broadcast theory that I've had scientists tell me, leave that part out, Ethan. Leave the idea that transmitters might be able to affect solar activity out of broadcast theory, because it's too mind-blowing. But the thing is that the data shows that some of the trends that our climate temperatures have gone in, specifically with regards to the early 20th century warming period, also began to play out in between solar cycle 16 and 17 to solar cycle 19, which was a huge peak. Solar cycle 19 was huge. Solar cycle, lots of sunspot activity happened then. But the more I began to look at these trends, and I had people share research with me, I found that I wasn't alone thinking this, and that if you look at the 11,400 years of tree ring data that can kind of show what sunspot activity has been like, because that affects X-rays coming into the planet's atmosphere and will affect tree ring growth. So you can go back and see 11,400 years of data stored in tree ring growth that show us solar activity. And what we noticed is that going back 8,000 years, they can see that there was an increased solar activity around just before 6,000 BC. That was around an average sunspot number of around 35. Okay, and then around 6,000 BC, it dropped down to 25. A little over 25 average sunspot cycle. Then in 1940, for whatever reason, right at the end of the early 20th century period, the sunspot number jumped up to an average of 75. It nearly doubled. And we have no idea why. Why did all of a sudden solar activity go boing? Like right around that period.
And then UFOs and UFO sightings go up, and all that kind of stuff starts to happen. No, I mean, like, you start to see in the nuclear plants, and the UFOs start coming right above the plants. And I mean, that could be some sort of, I'm not sure when those nuclear plants started being built.
Mm-hmm.
Do you know?
Not
I'm not sure
specific. Yeah.
when that
Yeah,
power was around. Wasn't it? Seems like it was right around the 30s and 40s.
I think it was around the 50s that a lot of the nuclear technology was coming online. The 30s, 40s, and then really in the 50s, it was starting to kind of, grow from there on a more global level. Yeah,
Interesting.
yeah,
Yeah, that's weird because like now you're tripping me out, man. This is
yeah.
like I've never heard this idea, and whether it's an idea or not, I'm thinking of it as almost like a conspiracy already. Like, holy crap,
Yeah.
dude, it's a big tunnel. This is definitely a big rabbit hole. Because if it is indeed something like that, where we increase our broadband and we increase our intelligence, we increase the sunspot, some sort of a weird solar connectivity, solar electric grid. I've been talking about this a lot. That's interesting.
Well, there's one thing that I want to just kind of nip in the bud with regards to like some of these dynamics and the word conspiracy. I just want to
Well,
nip
I
this in the
just
bud
had to say
because
conspiracy because it's fun. It's something
yeah,
that sometimes the
it's
conspiracy
interesting.
goes farther than the truth nowadays. You know what I
Right.
mean? It's not a bad thing being labeled a conspiracy.
Well, yeah, but I think the thing is that the idea of a conspiracy is that there's some intent to conspire, and one of the
Right.
things I want really crystal clear, like with regards to, because a lot of people will come to me and they'll say, "Oh, like they're generating this space fence." Like intentionally creating a space fence as a conspiracy to do this. And I'm like, I have to like kind of say this, that we started generating and using very low frequency transmitters for submarine communications before we even knew we had a magnetosphere. So
Right.
this was used as a practical like communications technology before we even knew that could affect any of
Absolutely.
these other.
Yeah, absolutely. But I've never heard anybody talk about it in the manner that you're talking about it.
Yeah,
It makes a lot of sense.
yeah,
Conspiracies make a lot of sense, is what I'm saying. This
yeah,
is
yeah.
a
Some of
conspiracy.
them
This
do.
is a this is like this is something that um the data is backing up,
Yeah,
and it's really like this could explain like the quantum tunneling of some people believe that we're going to hit what is it, the singularity point of information,
right.
and no, there's no singularity point for information. I'm here to pop everybody's bubble. It doesn't happen like that. We don't all of a sudden know everything, and there isn't something that just knows it.
Yeah.
Even if we come up with the intelligence, we're not going to get to that point, I don't think. I think it just keeps going and going. The depth of information is infinite. The well is all things. You know what I
I
mean?
like that. I like that. I'll let you do the bubble popping. Pop, pop. There's one thing I wanted to mention. I think you'll really love this. Is that how we were talking about the ion cyclotron waves that spiral through these tubes in the layer of the ionosphere? So transmitters can stimulate these ion cyclotron waves. Now, here's the really fascinating thing is these ion cyclotron waves not only have been observed traveling through tubes in the layer of the ionosphere, but they have also been observed by satellites traveling up the solar wind toward the sun.
As tailspin, as tailspin, or what?
It as you have energy coming away from the sun, but there are actually ion beams and cyclotron waves and proton beams traveling toward the sun. So this idea that energy is only coming out of the sun is false. There's a
Oh,
two-way electrical connection that happens between the Earth and the sun. And some of these waves have been observed along with ion acoustic waves and cyclotron waves moving into the convective region of the sun. One of the
now this
satellite
is going into the sun, is what you're saying?
Yes, the Core 2 instrument has observed these Alphaean ion cyclotron waves going into the sun, into the convective region. You see all this energy streaming out of the sun, but then you see these baby little plasma waves
No,
just going right down. Yeah, I can share the research with you. It's mind-blowing.
dude,
It's
that's like
really
sperm and egg
fun.
shit right there. That's
Yeah.
crazy.
Yeah, it's pretty cool. I
That,
thought you'd like that because the spiraling energy, it doesn't just happen here or on Jupiter. It goes upward against the power of the sun, right into it. Oh man, it's really
cyclotron waves, aren't those like the geometries of like butterflies? I keep looking up the geometry of them, and I found a couple of examples, and they break it down like a butterfly, and I break those down further and look at them and find the geometries inside of what I'm doing, because I see, excuse me, sorry there, I because I see butterflies and all sorts of the stuff that I do, and that is also the same type of geometry that um, the gentleman who came up with the simoscope, John Anthony Reed.
Hmm.
I think he was talking about this in one of his recent talks about. Oh, sorry about that. Sound scaffolding and uh, um, now I lost the train of my thought, but
You're talking about cymatoscope and the cyclotron waves potentially relating to butterflies.
oh yeah, yeah, yeah. And he literally was working with this artist that's doing this and river patterns and bubbles inside of streams and river
Yeah,
patterns,
yeah.
and you get those type of butterfly shapes, and those are
Okay.
like I idyllic are of those types of interactions,
Yeah.
and I see these inside of the I guess, I mean, I could just show you, but if people want to hashtag love is watching on Facebook, you can find it for yourself. And but these this this is the same cyclotron resonance that gives us a sunburn too, right? That's what I found
Well,
out.
they're a bit different, really, because sunburn is from ultraviolet rays from the sun. Um, so that's kind of a little bit more of an energetic radiation. Cyclotron has more specifically to do with the cycling of electrons and ions, like almost a tunneling effect, a
Yeah,
spiraling tunneling effect. So, like with regards to to butterflies and the butterfly effect, for example, you're diving more into chaos theory,
well, I
and
know the butterfly effect. That's a little different, but yeah, what I'm talking about is the pattern, like you said, the way that they cavitate, the way that they
oh,
cavitate down the
cavitation
tubes
shapes.
creates
Yeah.
butterfly patterns.
Oh, I
Um,
see what you mean.
yeah,
Yeah.
and like I'm a guy that notices the
Yeah.
geometry, so I'm
The
seeing things.
turbulence. Yeah. The
Yeah, and
turbulent spirals,
exactly.
eddies, the
Yes.
whirls. Yeah, that can generate, kind of similar to what we were saying about, the Jovian picture that shows these whirlpools of electrical dynamics happening between the layers of the ionosphere. And those are perfect examples of these eddies and whirls, that happen throughout nature. And I think that's within that you can get these cyclotron energies that literally spin up between this connection, that are trying to reconciliate the differences between these differing forces, these dichotomous forces, between the E layer. Yeah, it's
Okay,
pretty.
my mind just keeps going back to why in the heck does the auroras, the sounds of the northern lights sound exactly like ice cracking and all living creatures. It just mimics it. I think that there's
Mhm.
mimicry on all scales happening, and this is the it's not cacophony, it would be the harmony
Oh, that's
of the
beautiful.
breaking and fracturing of sound into its compartments, its containers.
Right.
Like life can only exist inside of certain size vessels. That's a fact.
Mhm.
Um, and I was studying this guy Jeffrey West, and he talks about the scale of the metabolic system of all creatures, and how we all have the same amount of heartbeats. Just
Yeah, yeah, I've heard about that.
it's great.
Yeah.
It's so mind blowing. You're like an elephant is identical to
The
a
mouse.
shrew.
Yeah,
Yeah,
right.
a tiny
Totally.
mouse,
Yeah,
and they experientially experience the same lifespan too.
yeah.
Now that is
Mhm.
time dilation,
Yeah,
scale dilation.
yeah,
And I don't know, that's just some crazy stuff
yeah,
that I think about.
yeah. Well, I think when you're talking about the sound of the aurora and the crackling sounds, like some of what you're hearing are like, some of these like chemical reactions that are occurring as electrical potentials are trying to find their equilibrium in the upper atmosphere. Some of this you can also hear in spherics. You hear the crackling of lightning
Mhm.
happening and thunder, kind of like tying it back to what you were saying before. These aspects of the sound of thunder being a crackling, or just a thunderous sound that kind of resounds throughout the Earth ionospheric waveguide. You know, these are dynamic processes, and what I'm really curious about is, are some of the aurora borealis, like, are some of these actually enhanced in ways by our anthropogenic broadcast, signatures, like signals going into the atmosphere? In the polar regions, there is auroral electron precipitation. And my question is, how much of that auroral electron precipitation that's constantly streaming would actually shift or change in some way if we changed our electromagnetic output at various frequencies on the planet? How would some of these very natural, like what are considered natural dynamics, change if we were to turn the signal off and listen, really, really listen to the sounds of nature?
Have we turned off the grid ever before?
No.
No,
No. I
have we
mean,
turned off those, very large frequencies? What is the
the,
VLF
the
transmitters before?
The VLF transmitters are turned off individually for routine maintenance. And
Okay.
so using that and sometimes extended periods. So scientists, knowing that, would look at the data of satellite observations, and what they found, at least with that Northwest Cape transmitter in Australia, the largest one in the world. It's the most influential. I would say, because of its equatorial like location. It's closer to the equator and it has a lower frequency. That makes it more influential upon magnetospheric particles. But what that has created is it's created a huge horseshoe arch that goes from the southern hemisphere to the northern hemisphere in the magnetosphere. And they've actually, the Chinese CSES satellite detected an interaction between the power grid of the Chinese power grid interacting with the Whistler mode waves of the VLF transmitter in Australia. They found that there's actually some kind of weird interaction that's happening between the Whistler mode waves in those. And that horseshoe arc of electron precipitation that's happening extends over eastward over the Pacific Ocean. This is a huge signature that happens in the upper atmosphere, right over the El Nino, like the El Nino effect that happens in the Pacific. So where this temperature differential,
it would naturally go there anyway, though, right?
Yeah, exactly.
Because that's the spot where all the excess goes, and it turns into the El Nino.
Yeah. And so sometimes, like there was back in 2008, the Demeter Satellite noticed that there was an interaction between the transmitter north of Seattle, Jim Creek Naval Station, and the Hawaii VLF transmitter. They found that there was an interaction between those in the upper atmosphere that caused ionospheric heating off the west coast. And there was also electron precipitation further north. Now, in that region, there's a blob of anomalous, warmer than normal ocean water that is occurring. And
right now.
It's happening now. It happened last year, and it was prevalent, I think, in 2015 and 2013. So it's they're still trying to figure out why it's happening, but it does seem like when there's an increase in this warmer than normal water off the west coast called the blob, that's what we call it, there's also an increase in forest fires and forest fire activity along the west coast. And that's where I'm thinking some of these magnetospheric whistlers are coming down. Literally, these are microwave beams potentially coming down and microwaving the vegetation. That's what microwaves do. They will heat things from the inside out. Yeah. They will heat up metal pipes and wires in homes, cause arcing. This is what microwaves do. And there's a potential that these are beams.
So can they be, so that's the destructive nature of them. Can they be constructive, like life forming?
Well, sure. Like if you, yeah, I mean, they could be potentially constructive. I think that, you know,
that's what you're talking about right now, terraforming. You know what I mean? I mean, it's pretty much like if you move this energy around the grid in certain ways.
So think about it like this. If you heat the ocean water, say the West Coast, let's just say hypothetically, the West Coast power grid is causing these Whistler mode waves to self-amplify, charge the magnetospheric ducts to create these maser beams that come down, heating the West Coast water. Now, what you have is you'll have some life will die, but that death will bring other nutrients into the water that will then breed new life. So, and
an algae plume, you know, ultimately.
Algae plumes, you get new life coming out of death.
Yeah, essentially. And that's what happens with, it's already been proven, the more the higher the carbon level goes on the planet, the more life increases.
Yeah.
The more new life forms come into existence.
Hmm.
It's
And
not a bad thing. Why are we fighting against it? It's like a death cult fighting
well,
against something that's very, very uh, cornerstone for life propagation, right?
well, yes, I want to say here that, in defense, all right, this is in defense of our current, not Kermit, but our current climate change paradigm is that the father of our modern climate change paradigm was Gilbert Plass. He was, really kind of solidified what now is known as our CO2 climate change paradigm. He solidified that in 1956, and to his due diligence, he did ask, "Does anybody have a better idea?" He did ask. He said, "Hey, look, man, I don't know what's going on. Does anybody have a better idea?" But the thing is in 1956, we hadn't even discovered the magnetosphere yet. That was still 2 years down the timeline. So at that time, we had no other ideas to go on. So that's where it was born. And so I think that really has got us to look more at how are we impacting our environment? How are we doing this on a larger level? You know, whether or not that I do think that it question even our own conclusions. The thing with Gilbert Plass is that if Gilbert Plass had asked, "Does anybody have a better idea?" in our modern paradigm, where people who questioned the current paradigm are labeled deniers. They're labeled deniers. Gilbert Plass, ironically, would be labeled a denier in our modern climate change, and he was the very father of this.
Climate
So
change.
it's freaking ironic, you know. So what I'm saying is we need to constantly
That's like
question
Jesus. That's
conclusion.
like Jesus would be against religion, because it's not about a person. Christianity.
Yeah.
What?
So, I mean, we can argue and look at these things, but the moment that we start to draw conclusions on these questions, we stop asking the really good questions that need to be asked. Whew.
Man,
I
man,
about this, man. Ah,
what a freaking amazing episode, dude! This has been lit. I've
well,
learned so much in this short episode. I'd really love to have you come back on, and I don't want to cut it short either. I want to ask if you have any more questions, or if you want to go in any other certain types of directions. Uh, it's been 2 hours, and we just hit the 2 hour mark. But those magnetospheric ducts, those are real. Is that something that's real? That's
oh yeah,
what.
those yeah, it's called magnetospheric amplification of Maser beams. Yeah, I can share with you some research, and
Geez.
there's a lot of research that's asking, like, what are these Maser beams that can potentially come all the way down to the ground, and what kind of impacts could they have? What's going on with that? So I'm realizing now why the 2 hour window is great, because then you have to pee after
Ah,
2 hours. And I'm like, almost had to take a break, but then it kind of chilled out for me. And I'm like, okay, I can do, like, 15, 20
and
minutes more.
I mean, I'm over here drinking still, freaking on camera unabashedly, and I gotta pee.
Yeah. But to answer your question, like, what would I really like want to be a takeaway? And like, if I were to explore, like, really, I think we need to just like keep the question of what is really happening in the upper atmosphere keep that question alive, because the dynamics that are going on are so complicated up there. And honoring that process of creating a hypothesis and using the scientific method to explore and test the hypothesis is not an easy task. We can't do it with our current climate system because it's too complex. We can't run repeatable experiments. So the best thing we have are climate models. And over time, we have had these piecemeal chunks of climate models that are now starting to come into these bigger, more well-refined climate models. In the next 2022 IPCC climate model, they're now looking to incorporate some of this upper atmospheric particle forcing. I have been waiting so long for this. I've been doing research on this since 2006, 2007, and I've just been waiting for this beautiful moment where we're starting to get it and it's starting to come together. So I say, let's keep this question and learning alive. Let's keep our explorations of how these dynamics work together. Let's keep that alive, because within the divided view of our climate dynamics and climate change paradigm, it's going to be the unity that makes the difference. It's going to be us seeing eye to eye and beyond the differences that are really going to make us understand what's going on and what's possible. So I get passionate about it.
Hey,
But
man, that's the best way to be.
yeah.
That's the best way to be. So should we sun gaze? Should we look into the sun and the setting sun and in the morning sun?
Oh, I would say soak up as much beautiful sunset energy as you can while
Amen.
we can,
Yeah,
because who knows, man? Who knows how much longer we'll be here? So,
dude,
yeah.
this has been one of my favorite interviews of for sure, dude.
Oh, thank you so
I'm
much.
loving our chemistry. I'm really loving
Yeah.
understanding deeper layers of this, and I appreciate like just watching you. I feel like you're in a spaceship and like you're talking like a NASA astronaut. Like you're just so on point with your words. It's been a good definitely a good episode. Looking forward to hopefully doing another one with you here sooner rather than later. It doesn't matter to me. I'll just punch it in if not, part 2 or maybe down the road here.
Yeah, that sounds great. I
Because
have a lot of
I gotta do my research now. I gotta try to figure out exactly what this was and try
right.
to like put all these words together. And dude, now my mind is blown, and I love that because this is what I knew was going to happen. So I'm glad I made this happen.
Yeah, well, I really appreciate it, buddy. And next time I'll have some of my images available to kind of help illustrate the beautiful dynamics that I see, and we can kind of learn more and explore more of how we interconnect and our ideas. So
So
I really have a lot of gratitude.
thank you, thank you. I'm going to put your links below, but where can we reach out and find your best content right off of the mind here?
Right off the mind, you can go to broadcasttheory.com. Yeah, and you can also look up Ethan Clark, my profile on Facebook. I don't I post a lot of my new research and explorations on Facebook. If you're interested in really going through a mindscape of ideas, I through my image gallery on Facebook, I use my images to store information so I can access information quicker for myself. So I often, like, on images, I'll just post links that help me keep track of information, and I'll use that as a resourcing information, visual
Okay.
resource. So, but yeah, broadcasttheory.com. I just finished a 16-page article for a German magazine on transmitter-induced ozone depletion in the early 20th century warming period. It's Nexus magazine. That was a really wonderful article writing experience. They want me to come back and do a couple more articles. I'm probably going to do one on anthropogenic solar activity and another one on these maser beams. Really, really important content.
Yeah,
I want.
Maser beams. I really want to get more into those.
Yeah,
That's what was hitting it home. That's the
yeah,
cyclotron resonance, right?
yeah, yep. A lot of that happening through magnetospheric ducting.
Yeah. Well,
Yep.
I watched this episode of real quick. This murder episode of Murder in Alaska, and like they were talking about these crazy people that go crazy and they start hearing voices and they go out and like into nature and they don't come back. And then they started talking about cyclotron resonance and how it messes with their heads and stuff. And I was like, and then I looked into it and I'm like, oh, look, I found a butterfly and the patterns of it. And I'm like, that's the same butterfly that I work with. And I'm like, it was more of a tie to just like, because there's just the weirdest patterns that I don't understand unless I see them.
Yeah.
And then I see someone else in a scientific article and I'm like, that's it. That's exactly what it is.
Yeah.
And so like that's kind of my frame of validation. I draw it and then I if I stumble upon it, I stumble upon it and then I see it and I'm like, dude, okay, that's what that is. So
Yeah.
awesome.
Cool.
Well, yeah. So looking forward to next time, brother.
All right. Sounds good.
Peace out there in Washington. I didn't even get to ask what the weather was.
A beautiful sunset is coming out through the window. I'm gonna have to catch some of that.
Go get it, man. All right.
You
God
take
bless.
care.
Take care. Thank you for being here. Executive producer of Electric Universe Geometry is Buddy James. Music is by the acronym BUD. Thank you for being here. See you next week.